Dear students, let us continue our learning on the course Data Structures and Applications. This is the second session of the third topic of the module 5. The topics covered under this session are under hashing, types of hashing functions, that is static and the dynamic hashing, and address calibration sort, which uses the concept of hashing. Myself, Dr. Suresh.d from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. First, the types of hashing. So when we go to the hashing techniques, fundamentally we have the two different types of hashing, that is the static hashing and the dynamic hashing. First, let us start with the static hashing. Static hashing is a technique in which the table or the bucket size remains the same, that is fixed during the compilation time, is called the static hashing. The various techniques of static hashing are linear probing and the chaining concept. As the size is fixed, this type of hashing consists of overflow of the elements. Let us take the elements over here. So that is, let the elements be 24, 93 and 45. And the hash function we are using is modulus 10. So now how we will do? H of 24 will be equal to 24 mod 10, which will be equal to 4. Now in my hash table, the hash table starts at the index 0, 1, 2, 3, 4, 5. In this case 24 is yielding 4, so over the 4th position 24 is inserted. Next value be let that 93. It is a 93 modulus of 10, which will give us 3. That is 93 is inserted over here. Next 45, hash of 45 equal to 45 modulus 10, which will be equal to 5. Fine. So here the size of the bucket is fixed, that is the size of the table in case of static hashing is fixed. Fine. Then let's move that is such an hashing technique where the size is fixed. Then those cases we call it as the static hashing. But if I let me have one more method, one more value, let it be 73, h of 73. So if I take up the h of 73, it is a 73 modulus of 10, which is equal to 3. So that is now, but we have already 3 over here. Now we need to resolve it. The collision, what is happening, we need to resolve. For resolving this type of collisions, there are two methods are there. One is linear probing and other is the chaining concept, which we will discuss later after completion of the dynamic hashing. So the linear probing or the chaining, these are the two collision resolving mechanisms what we are going to study next. That is, static hashing means fixed hash size of the hash table. It is fixed. We are not changing the table size. It is a fixed hash table size. Then let's move to the next method of hashing, that is dynamic hashing. So this is a hashing technique in which the bucket table or size is not fixed. It can grow or shrink according to the increasing or the decreasing number of records. If we go for increasing the number of records, then we may go for increasing the hashing table, size of the hash table. Or if the number of elements are less, we can go for shrinking the size of the hash table. Fine. So both the options are available. Either we can go for increasing or decreasing the size of the hash table. Fine. So this type of hashing we also called it as the extensible hashing. So this hashing we also call it as the extensible hashing. So that is, we can go for extending or shrinking the size. Both options are available for us. That is, either we can go for, if the number of elements are less, we can go for shrinking its size, or if the go for the number of elements are more, then we can go for increasing the number of size. Fine. This extensible hashing is the technique which handles a large amount of data. The data to be placed in a hash table is by extracting the certain number of the bits. The extensible hashing refers to the size of the directory of the elements or to be placed in the buckets. Let us take the example over here. So first we will fix let us take the example bucket size as the 2 entries over here. Let me take the example for your binary cases. In the binary cases, I want to have a 2 bits for the each 2 bits for the each index. So how it will be there? First index will be for with the 2 binary bits. I can have the index values as 0 0. Then the next index value is 0 1. Next index value is 0 1 0, and the next index value is 1 1. So now I want to insert the values to this one. Fine. So now let me have the values as 1 4 5 7 8 10. So if I write this 1 in binary, this is 0 0 1. So then we take its ending last 2 bits. So now what is that one? So it is connected to a bucket. It is connected to a bucket. So now I will put my value over here 0 0 1. Then again 4 value is 0 1 0 0. So last 2 bits are 0 0. I will put the bucket value as a 0 1 0 0. Next one is 5. So 5 value is 0 1 0 1. The last 2 bits are 0 1. So I will put the 5 over here 1 0 1. Then the next value is 7. 7 is 111. The last 2 bits are 1 1. So I will put my values as a 111 here. Then the next value is 8. 8 is 1 0 0 0. So I will put the 8 over here. Then the next value is 10. 10 is 1 0 1 0. This 10 is 1010. Here I have my bucket. I will store the values as 1010. Fine. So here it is an extensible hashing, means we can, whenever we have the large volume of data, we use this extensible hashing. So wherein we can go for increasing or decreasing the number of elements which you store. In this case, I have stored 2 elements. Here 2. Here I used only 1. Here I used only 1. Fine. That is based on our requirement, we can go for the changing the size of the hash table. Right? If the 2 bits are, I use this one. Then 3 bits, it is in some other scenarios we are going to use. That is it. The bucket size, the size of the hash table varies depending on our requirement. Means the size is not fixed. Wherever the size is not fixed, then we go for the dynamic hashing concept. Okay? Then, so in case of dynamic hashing, there is no case of collision over there. Whatever our size is there, for that one we can go for the increasing the size. There is no such concept of collision over there. The collision mainly occurs whenever we have the fixed size hashing. There the collision is normally going to be occurred. Fine. So now to resolve the such cases, to resolve the hashing conflicts, we go for the collision resolution techniques, or we also call it as the overflow handling. Right? That is whenever we have the collision. So as we have shown in the static hashing, so whenever we have the collisions, there we go with the concepts of overflow handling or the collision resolution techniques. Fine. So first question, what is the collision then? It is a collision resolution technique is the phenomenon of 2 or more keys being hashed to the same location of the hash table, fixed size. That is your collision. That is if the 2 values, let me take the values as 23, 53. Let me take one example. And I use the mod 10 as my hash function. So mod 10 will give me the value as 3. 53 mod 10 will give me the value as 3. So in both the cases, I need to insert my, at the index value 3, I need to put these 2 values. First I need to put 23, then I need to, when I get the 53, I need to put the same location again. So now this scenario we call it as the collision. This scenario it is called as the collision, where the two entities are getting the same key. Two entities or two values, we are getting the same index for the hash table. So this is your collision. So now we need to go for resolving this collision. For resolving the collision, there are two important mechanisms are there. The first one is open addressing or the linear probing. First one is open addressing or the linear probing, and the second one is chaining. These are the two important aspects. The first one is open addressing or the chaining, linear probing, and the second one is chaining. This open addressing is a simple quiet mechanism. So here it uses a static hashing table. First, these will appear in the static hashing table. In such a table, collision can be avoided by finding the another unoccupied location in the array. Let me take some elements over here. I have the elements as 23, then the 25, 18, and I have the 15. Let me take. So now these values I need to insert. So 23 it is. So these values I need to insert. So first let me find its index values. 23 modulus 10, which will give me 3. Then 25 modulus 10 will give me 5. Then 18 modulus 10 will give me 8. Then 15 modulus 10 will give me 5. So now there is a clear collision over here. Now there is a clear collision. So if I go for inserting my values, first index value 3, 23 is inserted. So 23 is inserted here. Index value 5. My 25 is inserted. Index value 8. My 18 is inserted. Now next value is 15. So now I want to insert this. What is the index? 5. But 5 is already occupied. So now whenever we get in collision, then we go for inserting that value into the location which is currently unoccupied. Over there. Fine. So now after 5, which is the unoccupied place which is left out, and that is 6. To this location we are going to insert my value 15. This is how we go for resolving the collision over there. Such a mechanism we call it as the linear addressing or the linear probing or the open addressing. That is, whenever we have the collision, so what we will do, we check for the next available empty locations. So now we insert our value to the next available locations. Next, after inserting the 15, if I get my 26, now 26 mod 10 is 6. Now 6 is already occupied. Then what we will do, we will insert our 26 to the next unused location. Next unused location is 7. Here it will be inserted. So like this we go for resolving the conflicts. So such a resolving mechanism we call it as the open hashing, that is open addressing or the linear probing, and it is one of the simplest, easiest collision resolution technique. Fine. Then the second method. Then the other method for resolving the collision is the chaining method. So now if I go for the same table, but in place of open addressing, if I go for the chaining concept. So chain is nothing but we have seen the chain mechanism in case of the linked list. The same linked list concept we are going to apply. So now in the chaining techniques avoids collision by using an array of a linked list at the runtime. If more than one key has the same hash value, then all the keys will be inserted at the end of the list. Fine. So now if I go for inserting, let me rub this one. Fine. First, the first index, first value is 23. 23 is inserted as the first element over here. It is having a pointer to the linked list. That's it. So 23 is inserted here, and the link I don't have. Link will be made null. Next value is 25. 25 is inserted to the fifth index. Here the 25 is inserted. Next value is 18. 18 is inserted at the 8th index value. So next, once I get the 15, again so 25 is not inserted directly, instead it is used as a lister. 25 is inserted here. This is 8 is inserted here, it is 18. So next, when I get the 15, I have again the key value I getting as the 5. So now this will be inserted as a, it is an array of a linked list. So now I can have the insert the 15 over here. So when I get the 26, 26 is inserted to the next, it is 26. So such hashing technique we call it as the chaining method. That is, whenever there is a collision, if more than one key has the same hash value, then all the keys will be inserted at the end of the list. That is, inserting at the rear one by one, so that the collision will be avoided. So such a mechanism we call it as the chaining method. This is the chaining method. These are the two methods for handling the collision in case of the fixed hash. So one will be by using the open addressing or the linear probing, and other will be the concept of chaining. So chaining uses your linked list. Chaining uses the linked list for handling the collision. So that is, if more than one key is matched over there, it is just attached at the end, rear end. That is insertion at the rear end. So such these are the two ways of handling the collision in case of the hashing concept. Open addressing or the linear probing, and the chaining concept. And the next one, address calculation sort. So it is one of the important sorting algorithm which uses the mechanism of hashing. Right? So here the hash function should have the property of x1 should be less than or equal to the x2. Then their hash value should be hash of x1 should be less than or equal to the hash of h2. Okay. So now let us take the example, that then it will be much more clear. Suppose I have the elements as, so this is my condition. I suppose I have the elements as 25, 57, 48, 37, 12, 92, 86, and the 33. Right? So here how we work is here. The major feature of the address calculation sort is the hash function should possess this property. What is property? If x1 is less than or equal to x2, then our hashing should also yield the hash of x1 should be less than or equal to h2. So like that, you need to select your hash function. If I go for the modulus operation, what happens now? If I take up the elements 92 and the 37, and if I use the mod operation over here, so mod 37 will give me 37 mod 10 will give me 7, wherein the 92 mod 10 will give me 2. Even though the element value is less, but its key value we are getting high. So this can't be our hash value. We can't take the hashing like that. Fine. So we have to select the hashing such that if the element x1 is less than or equal to x2, then the hash value of x1 should be less than or equal to the hash value of the x2. So now to handle this case, fine. So now we have the 19. Now for that case, that modulus won't yield an correct result for the address calculation sort. So in place of modulus, let us try with the division operation over there. So 37 divided by 10 will give me 3, whereas the 92 divided by 10 will take only the integral part, will give me 9. So now does our property is preserved? 37 is less than 92, hash value of 37 is 3, hash value of 92 is 9. Yes, so it's absolutely preserving our property of if x1 is less than or equal to x2, then the hash value of x1 is less than or equal to x2. Yes, we can use this property. Now let us apply this property. Now let us apply this property, and so which is that one hash function we have decided. We will let us go with the division hash function now. So now I apply for the, so now this is my table. This is my table which will have the index value from 0 to 9, let us take. Fine. So initially no elements are there, so I will make all the link values as null, because chaining is the most important is the technique which will be applied for all the rest of the cases. Fine. 2, 3, 4, 5, 6, 7, 8 and the 9. So now all the elements will be, all the link will be made null. So this is \0 which symbolizes null values. First element 25. 25 divided by 10. So what is my result? 2. It will be inserted to the 2. Then the next value is a 57. 57 divided by 10, which will be equal to 5. Then the next value is a 48. 48 divided by 10. 4. Next value is a 37. 37 divided by 10. 37 divided by 10 is 3. Fine. Then next, so suppose my next number is, in this case, let me take the next number as 38 or the 34. So now for the 34 divided by 10 again, it will give me the value as 3. So now we have already a 37 over here. So now it is nothing but you are inserting in between. So it will be nothing but you are inserting in between. Once we sort the elements, then first we go for initializing divided by 10. Again in that chaining, inserting at the position depends on its value again. So that is for the 3, all the elements from 30 to 39 will be stored. Then 4, 40 to 49 will be stored. So such a type of sorting we call it as the address calculation sort. Fine. So that is how it happens. So first we go with the, so now this is the case for the 2-digit number. In place of this one, so how we handle the 2 digits number? We handle the 2 digits number by dividing by the least 2-digit number, that is 10. By dividing by the least 2-digit number 10. So in place of this one, if I have the 3-digit numbers, then I will go for division by 100 first. Then again, so now how we have handled the 34, 7 and the 34, first case, 37 divided by 10, 34 divided by 10. So this will be 3, this will be 3. That is the first we have done the division by 10. So now this will be done, division by 10. Then the next one what we have entered, division by 1. That is your 7 we are going to get, here 4 we are going to get. So 4 will be inserted first, then the 7. Fine. Then if I have the 3-digit number, first I will go for dividing by 100, then I will go for dividing by 10, then I will go for dividing by 1. That is again each one, individual one. Again it is one more sort. Fine. So again it is a one more sort. Fine. So this is how the address calculation sort will work out. So this address calculation sort is based on the fundamental mechanism of hashing. So here the key feature of the address calculation sort is, if the value of x1 is less than or equal to x2, then its hash value of x1 should be less than or equal to x2. So for that reason, instead of taking the modulus as our hash function, here we are going with the division. And which value to take it as a divisor, always that will be the question always. So what we will do is, the highest value what will be there, we take the how many digits are there in it. So in this case, highest value is 92. How many digits are there? 2 digits are there. Then we take the least digit which is possible with the 2 digits. That is 10. That is our divisor. So if my digit is a 3-digit number, then it will be obviously 1002. That is a 1000. Sorry, 100. So like that, we decide the divisor over there. We decide the divisor. So once we have decided the divisor, then next, if there is a collision, then we go for sorting there. So in this case 37 and the 34, they are colliding for the position 3. So in that scenario, we go for looking at the unit place. Once you have done for the tens place, then we will go to the unit place. So 4 is lower than the 7. So when 4 is lower than the 7, 4 is inserted first, then the 7 is inserted. So that the list appears as a sorted one. And this is how the address calculation sort works. So this is the fundamentals of your, it is based on the fundamental concept of the hashing. So in this session, we learnt on the types of the hashing function. That in that one, primarily there are 2 hashing functions we have studied. One is static hashing and the other is dynamic hashing. So static hashing is a mechanism in which the bucket size or the table size is fixed. So when there is a fixed table size, there may be a chance of collision over there. For handling the collisions, the 2 methods were there, linear probing and the chaining methods are there. And the second method is your dynamic hashing. In the dynamic hashing, the size is not fixed. We can go for increasing or shrinking the bucket size or the table size depending on the number of elements. This is also called as the extensible hashing. Now for the collision resolution mechanisms, we studied the 2 collision resolution mechanisms. The first one is open addressing or the linear probing, and the second one is chaining. In the linear probing mechanism, whenever there is a collision, then we go for searching the next empty location. When we found that one, we are going to insert that colliding element over there. That is your open addressing or the linear probing. And in case of chaining, we use the concept of a linked list, wherein the linked list we go for attaching element by element whenever we have the collision over there. Then next we learned the address calculation sort, which is purely based on the concept of hashing. The references for this presentation are taken from the textbooks Ellis Horowitz and Sartasani, Fundamentals of Data Structures in C, 2nd edition, University Press 2014, and from the Data Structures of the Sham Outline series, revised 1st edition, Tata Microwave 2014. Thank you.